Hello. So it's a moderately cold evening in Berlin, and this is the day the Lord has made, and we will rejoice and use it to learn Flask. So actually, this is the final video that is going to give us some fundamental knowledge we need to be able to proceed to the next sections. And everything I have taught you so far isn't exactly Flask, but I believe those are skills that you definitely need if you want to succeed or if you want to do anything useful with Python and Flask. So I felt it is good for me to show you all that. And this particular video is going to be a session about the difference between monolith and microservices. And once you have an understanding of the differences between these two architectural designs and the advantages and disadvantages, we can proceed to start writing code in Flask to do awesome stuff. So we are just going to focus on this diagram here, and I'm going to explain exactly what they mean. Now I want you to keep your eyes on the top diagram. This line is what is separating the top from the bottom, and for now let your focus be at the top section. Now the diagram at the top depicts an architectural design or architectural style which is called the monolith design. Now, in a monolith design of a system or a software architecture, basically you have a solution or a platform you're trying to build, and you throw the entire code base into one repository, and there is no clear distinction between the different subcomponents of your system, and they also talk to the same database. So in this diagram, I'm trying to use an e-commerce solution as an example here. For every e-commerce solution, there needs to be an account and membership management module. There needs to be an inventory management module, a supplier management, shopping cart management, payment processing, shipping and deliveries, refunds and returns. And in a monolith system, all these subcomponents, which clearly are supposed to be separated, are going to be thrown into the same code base, and every single part of this e-commerce solution is also going to talk to one underlying database. Now, I can't think of any advantage of using a monolith system, or except maybe you are trying to cut down costs, which eventually is going to show up as a bad design and you have to pay dearly for that in the future. And also, because it talks to one database, there is a single point of failure for your entire system. And what it means is that once this database here goes down, nobody is going to be able to use your inventory management system, sorry, um, your e-commerce solution. And the reason is that the database that they all communicate with is down. So if it is a business, you are actually losing money for the downtime. What it means is that new members cannot sign up. People you have employed will have no work to do because they will have no way to capture inventory. You cannot do anything with your suppliers' data. People cannot shop. People cannot pay. Your delivery services cannot run, and people who have bought stuff and wants to return cannot be able to do that, which is going to generate fury from your customers. So this is the monolithic way of doing things, and software development has progressed over the years, and now everybody is moving away from the monolithic way of doing things, and we are moving towards an architectural design called microservices. So now we can come to the bottom section of the image. Now, in a microservice architecture, take note of this. The diagram I have drawn here is not describing completely what a microservice architecture should look like. There's liberty when it comes to your choice of design and how you are going to let the sub components communicate with each other. This is just a simple diagram to explain to you how you would architect your system, starting with a very simple view of the microservice architecture. So if we were to implement this e-commerce solution I described earlier using microservices architecture, what it means is that we would have to break each of these subcomponents into, I would call it a project on its own. And the beauty about having such an approach is that you would have teams with few people who keep laser focus on the objective of the subcomponent. So you have a team who is responsible for working on account and membership. All they have to do in your company is to build the modules that people will use to sign up and manage their membership on your platform. You might think this is going to let you incur costs, but actually that is not what it is. It helps you to build proper software that is easy to manage. You have a team that is focused on inventory management. You have a team for supplier management, shopping cart management, payment processing, shipping, refunds. And the beauty about the microservice architecture also is that each submodule, so in this picture I have 4 submodules, submodule A, B, C, and then D. Each one of these could be any of these subcomponents that we have identified in our e-commerce platform example that we are using up here. And what is going to happen is that each submodule is going to have a team of dedicated programmers or developers who are focused on building a very good solution as far as that subcomponent is concerned. And each of these submodules is also going to talk to its own database management system. You can choose to let all these subcomponents talk to the same database, which is arguable in so many ways because now databases are cheap. It is best to let each submodule have its own database. And when it comes to intermodal communication, because of course in an e-commerce solution somebody cannot log into the inventory management system and start capturing inventory information unless they have an account. You cannot come to the online shop and start buying things, putting things in your shopping cart unless you have an account. You cannot pay for items in your shopping cart unless you have an account. So obviously these subcomponents are supposed to communicate with each other. And one way, and note, I said one way of enabling the intermodal communication is through the use of APIs, and I'll show you how to build RESTful APIs using Flask in the future videos. But then it helps these subcomponents to talk together. So let's say submodule B is the shopping cart management system and submodule A is the account and membership management system. What it means is that your users are going to use your client, which is the web application or mobile application that you create in the end. And then in let's say client A is a mobile app, client B is a web application. Now if somebody is using your mobile app, they will sign up and that is going to talk to submodule A because that is responsible for account and membership. And once they begin to shop, they will be communicating with submodule B because in our example we said the module B is going to be the shopping cart management system. And then in the microservice architecture, one thing that is also usually done is what we call an API gateway. So basically the API gateway is a single source of access to all these submodules that you have in your architecture. Otherwise, your client will have to call different endpoints to access these APIs and submodules. But if you place an API gateway here, you give them a single point of access. So what it means is that regardless of whether your client wants to talk to submodule A, B, D, or C, it will still make a call to the API gateway, and the API gateway is responsible for routing those requests to the appropriate submodules. And once the response from those submodules are ready, it will be shipped to the API gateway, and the API gateway is going to send it back to the client. All these things are transparent to your users. They don't care how many hops their data makes to get to your system. They don't care how many hops the information they require from your service makes to get to their phone or their devices. All they care about is they made a request and they got an answer. Now let's look at some of the advantages of using the microservice architecture. Unlike the monolithic architecture we described in the first diagram, in the microservice architecture, there is no single point of failure. What it means is that if the DB for module A goes down, other users can still be accessing module B, module C, and module D. So for instance, let's still use the e-commerce platform as an example. And let's say that module A represents inventory management system. And for any reason, if your inventory management system goes down, people should still be able to shop on your site because they have no business with your inventory management system. All they are trying to do is to shop on your site, and they don't care if your inventory management system is down or your in-house employees are not able to capture new inventories into the system. So if the inventory management system database goes down or the submodule fails, people can still be able to buy things into their shopping carts. People can still be able to do payment processing, and your delivery guys will also be able to deliver products that have already been paid for. So in the microservice architecture, there is no single point of failure. And once a system or a component of your architecture fails, the other components are there to serve their purpose really, really well. And when it comes to deployment also, there is an advantage for choosing the microservice architecture, in the sense that we have two types of scaling. When we talk of scaling, is about increasing your computing resources to be able to handle your increasing number of requests. So for instance, if you build a system and it's 7,000 users per second, and you have a good business with that system, let's say in 6 months time you are serving 10,000 requests per second, it will start showing. I mean, the increase in customers, the increase in usage is going to start showing. You will see that your systems will start slowing down because your resources are being eaten up. Now when it comes to scaling, like I said earlier, it is about increasing computing resources so that your increased traffic will be served properly. And what it means is, if you choose to do scaling, there are two ways of doing the scaling. Sorry, I've been confused here by some calls that is coming in, but I think I'm on track now. So when we talk of scaling, we have two ways of doing scaling: the horizontal scaling and the vertical scaling. Now, the horizontal scaling has to do with you increasing the number of computers available to your software to run on. And the vertical scaling has to do with increasing the number or increasing the computing power. Let me explain it very well. If I try to do vertical scaling, what it means is I'm trying to increase the CPU speed, I'm trying to increase the RAM size, and any other thing that I believe I can do to influence the speed at which my program runs. That is vertical scaling. And the problem with vertical scaling is that there is always a limit to how much you can increase the processor in a computer. There is a limit to how much memory, how much RAM you can use in a computer. So it is not a very good choice to make. But when it comes to horizontal scaling, what it means is that you are actually increasing the number of computers, and this times because of cloud-based systems, computers are cheap. You can always spin up a server for very cheap prices, like $5 a month and $10 a month, depending on the resources that are available to you. So we choose to, in the microservice architecture, we choose to go with the horizontal scaling approach. And what it means is that you can redeploy, you can deploy another copy of all these submodules, or you can even choose just one submodules and replicate it as many as you think are needed to handle the increasing number of requests that your service is receiving. So what you need to take home here is, in a monolithic system, everything is put together and they are all talking to the same database. There is a single source of failure. If the database goes down, your entire system goes down, and that is not good for business. In the microservice architecture, you break down your software or your system into components that are focused on specific business goals as far as your business operations are concerned. And once you build them, they are able to communicate with each other through APIs. And it is also good for each module to have its own database, so that you are insulated against the problem of having a single source of failure, in that once any of the modules goes down, the other ones are going to be live, and people who have no business with the module that is down will still be able to use your site or your software, and will not even have an idea that one of the components is down. And when it comes to scaling to the microservice architecture, makes it easy for you to scale horizontally, because now we have something we call load balancers. In future videos, I'm going to show you how to use load balancers in your code to deploy your code. But all you need to know is that a load balancer is a server that sits in front of so many servers. Now, what the load balancer does is, it sits, you can put one load balancer in front of, let's say, 100 servers, and the likes of Google and Facebook have thousands and hundred thousands and millions of servers sitting behind their load balancers. So the load balancer receives requests, millions or billions of requests per second from users, and the load balancer is going to route them to appropriate servers depending on the load on the servers. It is quite similar to the gateway concept that I described here, just that it is more of a computer that is trying to distribute system requests to servers based on the availability and how free they are. So basically, this is an idea I need you to have, and I promise you, in the next video we are going to start working with Flask. So thank you very much for watching. Don't forget to subscribe, and don't forget to leave your questions and comments in on the video. I will see you in the next video. Thank you.